let's continue our conversation. You're going to be asked to do two things. One is to evaluate a trigonometric expression. The other one is to solve a trigonometric equation. Now, when you evaluate, you get a single answer. Okay? When you solve an equation, okay, you find every value that will yield a true statement. Now, sometimes since it's trigonometric equations, we are told that only find the solutions from 0 to 2 pi over a certain kind of interval, okay? But you're still finding every value that yields a true statement. Okay, so there is a difference between being asked to do this and then being asked to do this. Okay, so you need to be aware of what you're being asked. Okay, so now, okay, this is asking you to find the angle that gives you a sine ratio of 1/2, okay, according to its domain, which we discussed in the previous video. So this would be the calculator answer. If you're using a calculator, this would be the answer that your calculator would give you. So if I type this into a calculator in radian mode, okay, it's going to give me pi over 6. Okay, not too bad. And if I type this one in, it will give me negative pi over 6. Okay, and that's because the inverse is only defined for a range of negative pi over 2 to positive pi over 2. So your positive sine ratios are in quadrant 1. Your negative sine ratios are in quadrant 2. Okay? All right. So one lives here, the other lives here. All right, now let's take a look at this one. This one says solve. Okay? So you put this into your calculator and say, okay, sine of x inverse and you pop this in your calculator, and the calculator spits out a pi over 6. And then you turn it in, or you hit submit or whatever, and you are told you got it incorrect. Okay? The reason you got it incorrect is because this is not the only value that works. Okay? Remember, sine gives you a positive 1/2 on the unit circle in 2 locations. One in quadrant 1 and one in quadrant 2. Or excuse me, quadrant 2. Okay? So you have this one as well, don't you? Okay. So if it says all, that means it wants all of them. And you know that cosine has a period of 2 pi. Whoops. So you have to add 2k pi on each thing. Okay, so this is pretty simple. It's on the unit circle. We can just look. Okay, but what would happen if we had something a little bit more complicated? So let's say I have sine inverse of 7/8. Okay, and I'm asked to evaluate that. Okay, so I get out my calculator because I know 7/8 is not on the unit circle. Okay, put my calculator in radian mode, type in 7 divided by 8, and I get x is equal to 1.065 radians. Okay. Okay, so that's pretty cool, right? Okay, but remember, things change a little bit when we're asked to solve. Okay, let's say we were asked to solve this equation. Okay, so we take the inverse sign just how we normally do. Okay. You type it into your calculator and guess what? You are given 1.065 radians. Okay, if you turn it in, guess what's going to happen? You're going to be marked wrong because you didn't find all possible answers. So what you need to realize is this. There's a second one. Okay, so let's draw that unit circle. Okay, so we know that sine is positive, whoops, positive here and positive here. This angle right here, that's your 1.065 radians right here. Okay, now the sine ratio is positive in the second quadrant too, so you need to find the companion angle. Okay, so these two angles are equal. Now here's the bummer part. That's not the measure of this angle. Okay, 1.056 twice isn't going to cut it. So what you need to do is you need to get a little creative. We know that angles are measured from the positive x-axis going all the way around. So if I have a terminal side, I need to figure out what this is. So what I can do is I can go pi minus 1.065. And if I do that, I get 2.077 radians. Okay, so that's one way to do it. Okay, so again, you have to be careful on what you're being asked. Okay, now I need to find all values of x. So x is equal to 1.065 radians plus 2k pi, and x is equal to 2.077 plus 2k pi. All right, so now what we're going to do is we're going to take a look at the graphs in the third video to see how the graphs can help us out. Okay.